in-class workbook. Okay, so I'm going to pull up the in-class workbook. I'm going to pull up both of them just in case. So we've got the in-class workbook right here. And if you come down here to the, let's see here, not the contingency table, nope, not the principles of counting. Okay. Is this exciting?
Yes.
What do you guys think? Yeah? Very confusing. So I want you guys to go to the prior, conditional, joint, and post. We're not going to get all the way to the post, but we'll do the prior and conditional right now. Okay? We have events. Okay? And we are going to label these events as A sub 1, A sub 2, and then I'm also going to label two events as B sub 1 and B sub 2. Okay? So here we go. We've got 1/4 of the residents in the Burning Ridge estates leave their garage doors open when they are away from home. Okay? How many?
I'm sorry.
1/4 of the residents of the Burning Ridge estates leave their garage doors open when they are away from home. What percent? All right, so 0.25. So that's the very first event. They either 0.25 leave their garage door open. If they are not leaving their garage door open, what are they doing?
Leaving it closed.
Leaving it closed, and what's the probability of them leaving it closed?
0.7.
0.75. So 0.75 is the probability of the other event. So A2 is the probability of them leaving it closed. A1 is the probability of them leaving it open. Okay? So the local police chief estimates that 5% of the garages with open doors will have something stolen, but 1% of closed doors will have something stolen. Based on the above scenario, fill out the value of each of the box. A1 is garage door open, A2 is garage door closed, B1 is something stolen, B2 is nothing stolen. So what is the probability of it being, so B2 is stolen. So we'll get there in just a second. We've got A1. What is the probability of them leaving the garage door open?
0.25.
So 0.25. We're going to put 0.25 right here. Okay. And then we're going to come down here. What is the probability of them leaving their garage door closed? 0.75. Okay. And so given that, okay, did you guys hear me say that? Given that an individual, okay, this little line right here means given that an individual leaves their garage door open, what is the probability that something is stolen? What did the question say? It said, if an individual leaves their garage door open, what's the probability of them having something stolen? 5%. So we're going to put 0.05. Okay. If they leave given that they leave their garage door closed, so that's really the way that this reads is what is the probability of, this should say B sub 2, I'm sorry. And that should say A sub 1. Don't you hate it when you mess up like that? Okay. What is the probability that nothing will get stolen given that they left their garage door open? What do you guys think? 0.95. Do you guys see that? 0.95. Okay. 0.95 is the probability. What is the probability that nothing will get stolen given that they left their garage door open? Okay. What is the probability of an individual? First of all, we've got their garage doors not closed. What is the probability that something will get stolen given that fun line right there? What does that fun line mean? Given that. So let's zoom in a little bit more. So what is the probability that something will get stolen given that the individual left their garage door closed? 0.01. Okay. And then coming down here, somebody read this for me. Tell me what this says.
Probability of them not getting something stolen, given that they leave their garage closed.
Yes, the probability that nothing will get stolen given that their garage door is closed. And what is that probability?
0.99.
0.99. Okay. So this adds up to what?
1.
And then this adds up to
1.
1. Okay. So we're going to keep the term given that. And then now we are going to say, what is the probability of A1 and, do you see that big word there? And probability of B1 given that A1. Okay, you guys tracking? Okay, so what this says is, what is the probability of the individual leaving the garage door open and they get something stolen? You guys tracking? What's the probability of both of these together? And the reason why I like this tree is because all that you have to do is multiply this by this, okay? Equals A1 multiplied by B1 given A1. And that gives you
0.0125.
0.0125. That is the probability of both of them occurring together. Okay? Oh, you're fine. I want you guys to be doing it, so you're perfect. So somebody tell me how to do this. What is the probability of an individual leaving their garage door open and nothing gets stolen given that they left their garage door open? So equals, what was that? 0.25 multiplied by 0.95, and that gives you the joint probability of 0.2375. So this is conditional. And this is, what is this referred to as? This one right here? Starts with a P and ends with a rier. That's prior.
Okay.
Okay? So we've got prior. In other words, is prior dependent on anything else?
No.
Okay. Is conditional dependent on anything else?
Yeah.
What is this dependent on?
Right.
It's dependent on the prior. Okay? And then is joint dependent on anything else?
Yes.
Yeah, it's both of them combined. It's the prior and the conditional combined. Okay, so moving down here, somebody tell me, somebody read this for me. Tell me what this says.
The probability of A sub 2 and the probability of B sub 1 given the probability of A sub 2.
Okay, well, just given A sub 2, not given the probability of A sub 2. But tell me what that means, though, in words.
Okay, so the probability that your garage door is closed and something is stolen given that it's closed.
Yes, the probability that your garage door is closed and something is stolen given that your garage door is closed. Okay, so in order to do that, it's equals 0.75 multiplied by 0.1, and that gives you 0.0075. Okay, and then last but not least, somebody else read this for me. Tell me what this says in words.
Probability of having your garage door closed and not getting something stolen given that your garage is closed.
Exactly. The probability that your garage door is closed and that nothing is stolen given that your garage door is closed. Okay, so we're going to do equals 0.75 multiplied by 0.99, and it gives you 0.7425. Okay? How you guys feeling about this? You feeling good? Okay. This right here is something referred to as posterior probability. We're not going to go over that this semester. Okay? But if you want to, you can feel free to read through it. You can look at the equations, and it's really great. Basically, what's the probability that something was stolen given that your garage door was open or closed? It's basically looks at the end result, and it says, based on the end result, I'm going to predict what happened to begin with, right? Which is pretty cool. So that is the